Hello students, welcome back to Vihan Pratik Institute of Education and welcome back to online mathematics classes. I am your facilitator M. Shiva Kumar. In last class we have seen problem number 4 and bit number 4. Now in this class we'll discuss problem number 4 bit number 5. Bit number 5 is cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equals to cosecant A plus cot A. Now we have to prove this LHS equals to RHS identity using one more identity. The identity is cosecant square A equals to 1 plus cot square A. Right. Now using this identity we can reframe it. We can write it in two different variations. One is cosecant square A. Now I'll bring cot square A from RHS to LHS. I'll write it as when plus cot square A comes to this side, or subtracting cot square A on both sides, we'll get minus cot square A equals to 1 is one variation. This is 1, this is 2. The third one is cosecant cot square A. Now I'm bringing cosecant square A to this side and 1 to this side. So plus 1 will become minus and plus cosecant square A will become minus. So cot square A minus cosecant square A equals to minus 1. This is third identity. So we have reframed it. Now we'll consider the same LHS or take LHS. LHS is cos A minus sin A plus 1 divided by cos A plus sin A minus 1. Now by taking this LHS we have to prove RHS. In RHS it has cosecant A and cot A. In LHS it has cos and sin. So what we do, we'll consider this equation and we'll divide the numerator and denominator of this of 1 by sin A. That's it. Very simple. By considering this simple step, we see that cos A minus sin A plus 1 divided by sin A whole divided by denominator cos A plus sin A minus 1 divided by sin A. Now segregate this cos A divided by sin A. Here we have sin minus, so minus sin A by sin A. Here we have sin plus, so plus 1 by sin A whole divided by, here cos A by sin A, segregating cos A by sin A. Here sin is plus, so plus sin A by sin A. Here minus sin, here minus, so minus 1 by sin A. Finish. Very simple. Now after doing this, we can see that here we can rewrite this equation as cos A by sin A is cos by sin is cot A, sin is minus, sin A by sin A is 1 plus 1 by sin A is cosecant A whole divided by cos by sin A is cot Sine by sine is 1 plus 1 by sine is, sorry, here sine is minus, here sine is minus, so write minus. 1 by sine is cosecant. Finish. Now what we have done, LHS is cos and sine, RHS is cosecant and cot. So to convert sine and cos into cosecant and cot, we simply divided this LHS equation by sine A. So we have converted this into cot and cosecant, right? But we need to arrive at this RHS. Okay, right. Now after rewriting this equation, we can rewrite it as cot A. Okay. So what I am doing here, I am taking minus as common. So 1 minus into minus is plus. So I have taken minus as common. So 1 minus cosecant A divided by cot A. Here sine is plus. I am taking plus as common. So 1 plus into 1 is plus 1. Here it is minus. Minus. Plus into minus is minus. Cosecant A denominator. So what I have done, I have made 1 minus common A, cos A as common in both numerator and denominator with signs changing. So we cannot directly cancel it. We cannot cancel it because here in the numerator the sign is minus, but in denominator the sign is plus. So what we have to do? We have to rationalize. We have to rationalize the denominator. Here denominator is minus. Cot A plus 1 minus cosecant A. So here sine is plus. So after rationalizing, it will become minus. So we will multiply the numerator. Rationalizing the denominator in the sense, multiply the numerator and denominator. Let's assume this as equation 2. Numerator and denominator of equation 2 by cot A minus 1 minus cosecant A. Okay, we need to multiply it. Okay, right. Now we'll do it in next page. So here what we have cot A minus 1 minus cosecant A divided by cot A plus 1 minus cosecant A. So rationalizing in the sense multiplying numerator and denominator by cot A. Here sign is plus, so consider minus. 1 minus cosecant A divided by cot A minus 1 minus cosecant A. That's it. Now let's see what it represents. Now this is cot A minus 1 minus cosecant A, cot A minus 1 minus cosecant A. So same terms. So if we assume the first term is A, second term will also be A. In between we have multiplication sign. So A into A is A square. But in denominator we have cot A plus 1 minus cosecant A, cot A minus 1 minus cosecant A. So here it is A plus B, here it is A minus B. But in between the operator is multiplication. So we write it as A plus B into A minus B equals to A square minus B square. So this is for numerator and this is for denominator. So now let's rewrite this. So cot A minus 1 minus cosecant A whole square, because A into A is A square, divided by A square minus B square. A square here, A is cot A square, B is 1 minus cosecant square A, 1 minus cosecant A whole square. Okay, now what we have to do? We have to expand it. We have to expand it. Okay, so expanding we will get cot a square plus 1 minus cosecant a whole square, a square plus b square, because this is in the form of a minus b whole square, which will equal to a square plus b square minus 2ab. So a square is cot square a, b square is 1 minus cosecant square a minus 2 into a is cot a, b is 1 minus cosecant a. This is the expansion of numerator. Now denominator is expanded as cot square a, in the sense cot square a, cot a whole square or cot square a, both are same. Cot a whole square is always equals to cot square a minus, this is in the form of a minus b whole square. So a square 1 square plus b square is cosecant square a in minus 2ab, 2 into 1 into cosecant a is the denominator. Now in numerator we again see that we have cot square a, again this is in the form of a minus b whole square, so we write it as a square plus b square minus 2 into a into b. Same what we have written in the denominator we have repeated in numerator, minus 2 cot a into 1 minus cosecant a whole divided by cot square a minus 1 square plus into minus cosecant square a minus into minus plus 2 into 1 is 2, 2 into cosecant a is 2 cosecant a. We'll continue this in next page. So from last page we'll rewrite the equation as cot square a plus 1 square plus cosecant square a minus 2 into 1 into cosecant a minus 2 cot a into 1 minus cosecant a whole divided by cot square a minus 1 square minus cosecant square a plus 2 cosecant a. Okay, now we expand it, we write it as cot square a plus 1 plus cosecant square a minus 2 cosecant a minus 2 cot a into 1 is minus 2 cot a, minus into minus is plus 2 cot a into cosecant a divided by whole divided by, here we'll rewrite it as cot square a minus cosecant square a minus 1 square is 1 plus 2 cosecant a. Okay, now from the identity we'll rewrite this identity. Identity is cot square a plus 1 equals to cosecant square a. So now cot square a plus 1 we write it as cosecant square a. So cosecant square a, this plus already we have cosecant square a minus 2 cosecant a minus 2 cot A plus 2 cot A cosecant A. This is the numerator. Now the denominator is, from this I'll bring cosecant square A to LHS and 1 to RHS. Both are plus. When they move away from RHS to LHS and LHS to RHS, their sign changes. So cot square A minus cosecant square A equals to minus 1. This is the denominator identity. So this I'll write it as minus 1. Already we have minus 1 plus 2 into cosecant A. Okay, right. In the numerator, cosecant A plus cosecant A is 2 cosecant square A minus 2 cosecant A minus 2 cot A plus 2 cot A cosecant A divided by, in the denominator, minus 1 is minus 2 plus 2 cosecant A. Now here we have cosecant A common, here we have cot A common. So we'll take cosecant as common, 2 cosecant A as common. So we'll get first cosecant A minus 1. Here we have cot A common. So here we'll consider first plus cot A, 2 cot A into cosecant A, plus into minus, we'll write minus 2 cot A into 1 is 2 cot A. In denominator, we'll write it as 2. In denominator, we'll write it as 2 cosecant A minus 2. So remember this equation, students. We'll continue in next slide. Now 2 cosecant A into cosecant A minus 1 in the numerator plus 2 cot A into cosecant A minus 1 in the numerator divided by 2 cosecant A minus 2. Now which will equal to, now these are two common, this and this. So taking this common, we'll get cosecant A minus 1 into 2 cosecant A plus 2 cot A. 2 cosecant A plus 2 cot A. Denominator, we'll write it as 2 common, cosecant A minus 1. So 2 into cosecant A is cosecant A, 2 into minus 1 is minus 2. Now which will equal to cosecant A minus 1, cosecant A minus 1 cancel. In the numerator we have 2 common. So 2 cosecant A plus cot A divided by, in denominator we have 2. So 2 cancel, which will equal to cosecant A plus cot A is the answer, which is equals to RHS. Please go through all the slides, students. Go through it, practice it. Whenever you got doubt, whatever doubt you got, please comment me in the YouTube channel or text me. Thank you, students. Please go through it. So I'll tell you from where we started the problem. We started the problem from slide 26. Here we have seen this multiplication. Then we continued into slide 27. In 27 we have this. Then we continued into slide 28. We have taken all these things common. Then lastly slide 29 is the answer. So we are asked to prove cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equals to cosecant A plus cot A. So we started with LHS, which is cos A minus sin A plus 1 by cos A plus sin A minus 1. We arrived at cosecant A plus cot A. Please go through it, student. Thank you.